So this video is about a wedge-dash and Fischer projection formula. What are the rules we have to follow to represent the molecule in wedge-dash formula, and how to convert wedge-dash formula into Fischer projection formula. So that is the discussion. So whenever the molecule is represented in wedge-dash formula, you have to use three types of bonds. One is a normal line, second one is a solid wedge, and the third one is a broken wedge. But at sp3 carbon there will be 4 sigma bonds. Therefore, we use two normal lines, two normal bonds, one solid wedge, and another one is a dashed wedge. A straight line represents a bond that is in the plane of the paper. Whatever the bonds you are writing, this is carbon. For example, here I am writing hydrogen, and here I am writing bromine. Whatever the atoms or groups attached to a straight line or normal line, they are indicating that they are lying on the plane of the paper. So here hydrogen is lying on the plane of the paper, bromine is also lying on the plane of the paper. Solid wedge, this solid wedge represents a bond that comes out of the plane of the paper. For example, same thing I am taking here, we have a hydrogen, this is a bromine, and here I am taking OH group, and here this is a solid wedge. This represents, this OH group is lying above the plane of the paper. So a wedge represents a bond that comes out of the plane of the paper and points towards you. For example, if you are observing the molecule, this is lying above the plane of the paper, and also we can say this is nearer to the observer. This is nearer to the observer. In general, the atom at the thinner end of the wedge is in the plane of the paper, whereas atom bonded at the thicker end is in front of the plane. So here this is what they are saying is, so here this is a thinner part and this is a thicker part, and this is lying in the plane of the paper, and this is above the plane of the paper. Bond here, that is dashed wedge, it represents that it is away from the observer, that is below the plane of the paper. So here I am taking the same hydrogen here, bromine here, this is OH, and here let me take this is ethyl group C2H5. So here this is in the plane of the paper, this is in the plane of the paper, this is above the plane of the paper, nearer to the observer, this is below the plane of the paper, and this is away from the observer. So if you take the example here, you can see all the 4 bonds. So here this is in the plane of the paper, this is in the plane of the paper, above the plane of the paper, and here this is below the plane of the paper. So this is a ball and stick model, you can see. So these two are lying in the plane of the paper, and this is above the plane and this is below the plane. And here when you are writing this dashed wedge formula, you have to use two V's. This is the first V, you can see alphabet V, and this is another V. While writing the first V, you are using normal line. While writing the second V, you are using, one is a solid wedge and another one is broken wedge. And you are connecting these two V's like this. As a result, you will get like this. So here this is the first alphabet V, this is the another alphabet V. These two are in the plane of the paper. This is above the plane of the paper and this is below the plane of the paper. You can see, so this is the first V and this is the second V, and these are connected like this, and you will be getting wedge-dash formula where 4 groups are indicated like this. And how to convert this wedge-dash formula into Fischer projection formula? In order to convert wedge-dash formula into Fischer projection formula, you have to see the molecule between these two bonds. So here this is above the plane and this is below the plane. You have to see the molecule between these two. When you are seeing the molecule between these two, So here this is away from the observer, this is also away from the observer, and you are representing like this. So when you are seeing the molecule from this position, you are going to see the molecule like this. So here this group is like this and this group is like this, and this will be coming right side and very clear. So this is coming right side, this is coming left side, and here this is away from the observer. This is, let me write, this is 1 and this is 2 like this. So this is 1 and this is 2, and this is right side and this is left side. If you want to convert Wedge-dash formula into Fischer projection formula, you have to see the molecule between solid wedge and broken wedge, and this will be away from the observer. You can see here this is away from the observer. So here if you want to convert one theoretical example, here let me take this is hydrogen, this is a methyl group, and here I am taking OH group, and here this is C2H5. So you have to see the molecule from this position. When you see the molecule from this position, this will be away, this is also away. So here like this. So here this is hydrogen, and here this is CH3. These two are away, and this ethyl group will be right side. So here this will be right side. So that is C2H5, and this OH is left side. So these two are nearer to the observer. So this is about Wedge-dash formula and Fischer projection formula.